Good morning. It's June 5th, and this is your daily brief in science. Here's everything you need to know. A coalition of AI and biotech leaders is urging Congress to require gene synthesis providers to screen customers and orders to prevent biological misuse. The letter, signed by figures including OpenAI CEO Sam Altman, Demis Hassabis, Dario Amodei, and Mustafa Suleyman, calls for mandatory screening of DNA and RNA purchases for dangerous sequences and for maintaining detailed order records to enable tracing of potential threats. It frames tighter regulation as a way to align rapid biotech innovation with robust biosecurity safeguards and notes ongoing debates about AI safety, biothreats, and regulatory approaches as capabilities expand. Today, many providers screen voluntarily rather than mandatorily, creating concerns about security gaps as costs and access to genetic materials rise. Experts see market opportunities in biosecurity AI tools, compliant DNA screening solutions, and real-time monitoring services linked with lab systems, while acknowledging challenges in balancing innovation with security and considering triage methods like federated learning and blockchain for traceability. The push is described as a proactive industry response to regulatory gaps intended to preempt blame and offer a bipartisan path short of broader AI pauses, with references to bills such as H.R. 3029 and S. 3741. The proposal would raise compliance costs for pharma and biotech but could create new revenue streams in risk assessment and regulatory audit trails, potentially differentiating companies that adopt proactive screening. Background context includes the Biden administration's April 2024 OSTP framework mandating screening for federally funded life sciences and a May 2025 executive order directing updates, though a new version has not yet been published. Screening frameworks exist through the International Gene Synthesis Consortium and federal guidelines, and broader measures from the Biden framework and bipartisan bills would formalize and extend screening obligations. Takeaways emphasize a June 4, 2026 declaration, the idea that advanced AI could lower barriers to misuse, and the push for a federal mandate within the current session to avoid patchwork state laws, with compliance costs for synthesis orders in focus. Wildfire smoke is not just a local nuisance. Scientists link it to higher ozone levels and estimate 318 additional U.S. deaths per year since 2013 due to ozone exposure. Researchers built a high-resolution nationwide ozone dataset using AI because EPA ground monitors cover only about 2% of the country, allowing assessment of smog trends beyond cities. Health and policy experts say current air quality standards aren't keeping up with wildfire-driven smog, fueling debate over regulatory strategies across administrations. Ground monitors miss regional patterns, so NASA satellite data and models provide national-scale insights that complement the ground network. The study places wildfire-linked ozone in the broader context of U.S. air quality trends, with attribution to AP science writer Seth Borenstein and emphasis on geographies and timelines. Fire AQ, supported by NASA, blends satellite data, models, and fire aerosol products to inform weekly briefings for state and local officials about predicted smoke movement and pollution risk. Lead author Weiji Deng and co-author Meng Zhou are highlighted, with commentary from Christina Archer and Christy Abe. Although cutting traditional emissions reduces some pollutants, wildfire emissions erode those gains and raise questions about wildfire management, land use, and climate action. The analysis notes policy changes under the Biden administration and prior Trump-era adjustments to smog rules, underscoring concerns about current standards for public health. Mitigating climate change and enhancing fire prevention could improve air quality and public health, according to the study. Cleaner air progress has stalled or reversed due to wildfire activity, signaling a need to rethink air quality strategies in light of climate factors. NASA's Tempo mission, launched in 2023, provides hourly high-resolution daytime measurements of North American air quality, enabling detailed detection of surface ozone patterns. A new €92 million boost from the European Union aims to expand ocean monitoring with underwater drones and ocean-focused satellites, positioning Europe as a global leader in ocean intelligence by 2035. The funding will support private ocean tech incubators and strengthen institutions like the Global Ocean Observing System, expanding data access for governments, researchers, and industry. The plan seeks to broaden the data landscape to close biodiversity and seabed knowledge gaps for better fisheries management, marine protection, restoration, and climate adaptation. Officials frame the program as essential for applications ranging from climate resilience and environmental protection to practical uses in shipping, aquaculture, coastal tourism, and naval operations. Proponents say comprehensive ocean data can close knowledge gaps and enable smarter management of fisheries, protected areas, and climate responses. Robotic sensors and satellites will feed data to shipping, fisheries, emergency services, research institutions, and naval operators to support informed responses to climate impacts and ocean management. Leaders including Ursula von der Leyen, Ekaterina Zaharyeva, and Kostas Kadis emphasize leadership and cite a projected return of €5 to €6 in benefits per €1 invested, calling for public awareness and strategic sovereignty in ocean observation. Von der Leyen has said the initiative will help us understand our ocean and secure our future as part of science-based governance. France is highlighted as home to the bloc's largest ocean science infrastructure, reflecting its extensive maritime interests. Officials argue that ocean monitoring is critical amid heat waves, stronger storms, overfishing, and pollution, with data guiding regulations and conservation. Experts note the practical value of ocean data across sectors such as aquaculture, shipping in icy waters, coastal tourism, agriculture, and naval use, underscoring broad societal importance. The United States is planning cuts to its Ocean Observatories initiative, potentially reducing real-time ocean data availability and prompting European strategic investment. Bees solved a novel problem by rolling a foam ball under a blue artificial flower, climbing on it, and reaching a sugary reward, all without prior training, in a setup adapted from the classic box and banana puzzle. The researchers emphasize they are not claiming human-like thinking, but they show miniature brains can support adaptable, goal-directed behavior in surprising ways. The study builds on evidence of cooperative problem-solving in bees and tests whether bees can independently solve a problem similar to the box and banana task. They acknowledge limitations, such as not tracking gaze or real-time cognitive processes, and call for further work to explore causal understanding and underlying cognitive mechanisms. Experts James Nee and Natalie Hempel-de Ibarra highlighted the work's significance for rethinking animal intelligence and the potential for flexible insect behavior. The study by Dr. Ali Lukola and colleagues at the University of Oulu suggests insects may have more complex cognitive abilities and emotional states than commonly assumed. While advising against overgeneralizing to human-like thinking, the researchers argue insects may belong in discussions of spontaneous cross-species problem-solving. Findings are published in Science. The work suggests cognitive abilities in bees that do not depend on large brains, given bees have about 1 million neurons versus humans roughly 86 billion. Researchers note neuron count is not the sole determinant of cognition and consider ecological needs and brain-body size in interpreting results. Independent experts, including Professor Lars Chitka, view this as the clearest demonstration yet of some comprehension and deliberate planning in bees, challenging the view that intelligent behavior requires large brains. The researchers plan follow-up work to monitor physiological responses and determine whether bees experience an aha moment or understand the physical properties of objects involved. A newly identified dromaeosaurid dinosaur, Jianchangmensis, from China's Changma Basin provides the first fossil evidence that a non-avian theropod preyed on early birds about 120 million years ago. This discovery places non-avian dinosaurs in an ecosystem rich with fossil birds, offering crucial ecological context for avian evolution in the region. Jianchangmensis is the only non-bird predator at the site, shedding light on predator-prey dynamics and the broader ecosystem of the early Cretaceous. Researchers plan to analyze the wing to assess flight or gliding capabilities and to scan for more functional details. It is hypothesized that this species hunted by snatching early birds from the sky, likely maneuvering through lakeside forested environments. The specimen supports the idea that Microraptorans used a four-winged gliding mechanism, an intermediate stage in flight evolution and a key piece in predator-prey dynamics with early birds. Microraptorans had feathered adaptations enabling gliding but not powered flight, indicating early flight-related capabilities. Understanding Jian's ecology helps reconstruct ancient food webs and the pressures shaping early bird survival and flight adaptations. Jian changmensis was roughly the size of a barn owl and likely capable of gliding between trees, suggesting arboreal predatory behavior more bird-like than previously understood. Size estimates place Jian within the Microraptorine range, and it may have preyed on birds such as Gansus yumanensis at the site. The species name honors the Changma Basin and references a mythical one-winged bird, highlighting its bird-like traits and potential arboreal lifestyle. The research was a collaboration between the Field Museum and the Carnegie Museum of Natural History, with findings published in the Annals of the Carnegie Museum after fossil excavation, comparative anatomy, and phylogenetic analysis. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.